Hello, hello, amazing hackers. How are you all? Just before starting, can we have a quick sound check? Let me know if I'm audible enough. Hello, am I audible? I think I'm audible. Can someone confirm? All right. Is my voice clear enough and the video as well? Because it's heavily raining at my place and my network is kind of a glitchy here. So I'm kind of somewhere between. Anyways, before starting, this is the last session of today's. That is the second last day of MLH INIT. And talking about MLH INIT, I started my coach's journey last year. Before, not only particularly coach's journey, but the hacker journey last year through MLH Local Hack Day and Global Hack Week as well. So it is kind of very special for me. And today we're gonna do something very cool, that is trying out hardware without hardware. True but not true. We're gonna try out all the hardwares on emulators. Well, there are a couple of hardwares emulator, but there's one named ThinkerCAD that has helped me a lot while learning IoT. That is why we'll be having this particular session to explore possibilities via emulators. Although we cannot move directly and use these emulator hardwares on cloud, at least not the ThinkerCAD, but there are many more cool things we can do on the emulators. So before starting, let us see what we have to do before trying your hands on emulators. First, we have to check in to Global Hack Way. Just let me quickly have my screen share. Let me quickly open the links. By the time, if you have any questions, please do ask. I'll quickly put the screen share over here. So first you have to check into the day 6 of the event if you haven't. And in case you have checked into the day 6, you're gonna have to also check into the event, of course, because you need to earn points, of course. So we're gonna have this link for screen sharing. Just a second. All right. I guess this is the day 6. And the other thing we have to have a look is and have checked in on is the event link. In case you don't have the links, I'll quickly put it up on the chat as well. I guess someone has already did, but I'll do it so that it can be posted both on YouTube and Twitch. I have added both the links to check in. So let us wait for a while, like guys, 2-3 minutes, and then we can, I guess, start the session. Before starting, it would be a request everyone to make account on ThinkerCAD. I'll quickly paste the link of ThinkerCAD as well on the chat, so you can make an account. I guess you can log in via Google as well, so it's not be a much problem for you. So let me know when you're good to go, so we can start the session and explore ThinkerCADs as well. Just let me know once you all are ready, so we can start the session particularly. And by the time, I'll quickly check if the audio and video is correct from my side. And let us see what we're going to build today, particularly on ThinkerCAD. So how many folks are doing in hands-on, by the way? So I'll be having a quick run through that who are following around. And really, uh, sorry if you feel any glitches on my video, because it's heavily raining this side. My Wi-Fi is probably not working that good, but I'm trying my best to work on mobile internet as well as other services I have. So by the time you check in and see what is ThinkerCAD, I'll give you a quick walkthrough. I'll quickly log out if possible and check uh, and quickly give you a demo. Basically, ThinkerCAD is an emulator for hardware, as well as you can make on 3D prints like AutoCAD, and it has been made by Autodesk, I guess you know. So I'm gonna log in via Google itself. So it would be easier for us to log in and make sure everything is fine. All right. So here I have logged in. All right, so here are some of the things you can do with Tinkercad. Well, there are different things you can do. You can either make it is basically an education software. So you can make classes, you can make 3D designs, you can make circuits, you can make code blocks, and there are some lessons as well, which is somewhat for that is something related to education and classes. So these are the projects which I try out usually. Since the time limit is very limited, we're gonna not make big projects. We're gonna simply try out different things and different circuits, so it will be easier for us to understand and easier for us to follow along. After that, I'll also give you a demo of different softwares I made using Tinkercad. Not particularly software, different hardwares I made during Tinkercad using Tinkercad, so it will be easier for you to understand as well. So first of all, you have under Tinkercad, you have to go on the left menu bar on the circuits, and then we have to click on create new circuit. So it's gonna give you a new workspace where you can create and emulate all your workspaces. Giving you a quick walkthrough to the software, we have a couple of things over here. We can change out different types of automatic wires, different types of wires. Basically, we can give out the colors to the wires. We can see the nodes. If I particularly don't have any nodes because it's a pretty new workspace. You can also add nodes over here, but I'm not going to do it since it's a pretty simple thing to do. And also we have different types of components. Note that the components here are pretty limited. Reason being, we are having not much things we can do on emulators because there are many things which comes as a barrier, but still we're going to try out different things. For example, we have the first very thing is Arduino Uno. So what exactly is Arduino Uno? In case you don't know, Arduino Uno is basically a hardware. Very simple. Basically, it's an open source microcontroller board based on microchip. I guess it's some kind of microcontroller. I'm not sure if I'm right, but it's 80 mega 328P microcontroller. It is developed by my Arduino. The board is equipped with different types of digital and analog pins, which works differently over different places. Also, we have a couple of other features here as well in our basically board. We have 40 digital pins, 6 capable of PWM output, 6 analog IPO, input output pins, and a programmable uh, interface. So basically, you can write out the code here. I'm not gonna code on block because I don't particularly like code blocks. Although it's different, I am a person who writes different types of codes directly over here. And since it's is somewhat related to code, we Arduino, at least this emulator works on C++. We usually code Arduino on C, C++, or Python, as far as I know. But there are different features also you can try, different languages also you can try if it's possible. Particularly, we're going to work on Arduino. Another thing, important thing here is breadboard. I guess if you have attended different IoT workshops, we might have told you that what is a user breadboard. Actually, this is used to connect all the components together. In case you don't know, this is the positive and negative side. These are all vertically, I guess it's horizontally soldered together. So if we connect a wire here and we connect plus from here, it's going to be automatically connected. So I'm not going to do it right now. And also these are vertically connected to each other. So if I put something over here and connect a wire from here, it will automatically be connected. So other things, there are another some important things like there's an RGB LED, there's a photoresistor, there's soil moisture sensor, there's a piezo PIS sensor, distance sensor, temperature sensor. There are many more things you can do with Arduino. Since the time is very limited, we're not gonna do deep coding or vast coding over here. We're just gonna explore what types of things you can do with Arduino. Here, let me arrange both the Arduino boards together. By the way, if you have any questions, please do ask any in the between. I'll try to answer and take all the questions together or one by one. That is particularly the amount of questions I get. So if you have any questions, please do ask it right now before I can move into coding as well. So is everything clear about Arduino, Tinkercad, and emulators? Please do let me know. I'm waiting for your comments. It's basically the hardware. If you see the shapes, these are basically the hardwares. this is gonna work for you. This is gonna work actually for you when you are coding, or we're gonna write the code here, and these things gonna work according to the code. So these are the hardware. And note that if you go for the title, we are working here on using hardwares or exploring hardwares on emulators. So it is particularly, we do not need actual hardwares out there. We're going to use the figures, as you said, or the shapes you said, but this is going to work right now. So I guess let us start by coding a simple blinking LED. Uh, uh, Isha, I guess we cannot use Python as a programming language in Tinkercad as of now. We usually write these in C++, but I guess it's very easy. It's not very tough language to understand. It was the very first language I learned actually, and most over it is very easy to code in Tinkercad, so you can understand it more easier. I'll show you the demo. By the time you can see my screen, just let me know at any point of time if I lost any connection. Please put it in the comment box. I'm having my secondary phone to see your code, as my second screen is not working, and also I have no electricity at the moment at my place. So I'm trying my hard to cope up with the session. Note that we're going to use it in blinking LED. So let me quickly connect LED with cathode, anode, or anything. So this is the anode and this is the cathode, and we have put it on the breadboard. Let me quickly zoom it for you. As I said, this is somewhere we're gonna code over here, work over here. As I said, these three and these points are vertically connected to each other. So even if I put a wire from here and connect it to ground, it is gonna work. So for better UI and better appearance, I'll put quickly uh, arrange these boards together, so it can look something cool or something visible or interactive. I'll put one wire from here and connect it to ground. Okay, as you can see, we have one wire from here to the ground. As you can see, there are multiple digital pins over here. We can connect it anywhere in the pins, and we have to code the pins accordingly. Since it's an LED, it cannot take the 5 volts out input, so we're going to use a register. For using a register, I'll put register here. Note that if I put a register here, it is already connected to the anode. So the next very point, I'll put it on the 13th part. Now, here's we're gonna code how is here we have to code over here. So let us see, let us have the pin mode as 30 as the output. And if we see over here, uh, I'll quickly explain the code as well. Right. So you can see the void setup in pin mode. That is, we're going to program the pin accordingly. And pin mode 13, if you look over here closely, I have connected the anode of the LED to 13 pin number. So we are going to program the 13 pin in the Arduino, and we're going to run up loop because we don't want to stop the function of the LED after time. So I'm gonna first data write 13 pin into high. High means one, that is the power on. Will apply the power, or will supply the power for 13 pin, and the LED got a glow. High means the LED is gonna glow, and if it is low, the LED is gonna stop glowing. So if we start the simulation over here, as you can see, after each 1 second, the LED is blinking. So I hope everything is clear as of now. And do let me know if you want to see the code, and if you want me to add the code over somewhere and send it to you so you can understand. If you want, I can explain the code again. As you can see, first we're going to set up the Arduino, that is void setup, pin mode 13, which in this case will be the output. And in pin mode 13, if it's the output, we're going to run a loop. Data write 13, it's high, then the LED will blink, and the delay, there'll be delay of 100,000 milliseconds, that is 1 second, and data write 13 low. So after every 1 second, the LED will stop blinking. So you not need to find the wire. You just have to click between different places, so it will automatically connect for you. I hope it is clear. And also you can change the color of the wire, of course. I'll use one wire red and one wire blue. Yes, it's automatic. So I hope this is clear as of now. Let us add some multiple LEDs and make what say a Christmas light or Diwali lights as of kind of thing, so you can understand it more. Let me quickly note that you can also copy paste things here. So if you Control C and Control V, you can copy things over here. So okay. Also, I'm going to change the color of the light as well, so it will look more beautiful. Note that the patterns particularly belongs to you. Any pattern you want, you can do that. Now, I'll switch it somewhere below. Oh, no, that it is fine here. In case you don't know, these two lines or these two lines are central lines. So in case you connect any of these, it will automatically be connected over here. So in case I connect these into the cathode, positive end, I'll collect all of them to the positive end. Okay, hold it. Sorry, I deleted by mistake. I'm gonna need some registers. I'm gonna connect it to the negative end one by one. And then connect. All right. Since okay, I did some kind of a mistake over here. Since all the LEDs will work on different pins, since we are making I guess Christmas light, so taking it to a single pin won't work. So let me quickly disconnect all of the wires and connect it again. I realize it's pretty soon, I guess. Yes. So I'm gonna connect all of it to the ground. Okay. And let me quickly do it again. I messed up pretty. No worries. I'm gonna fix it soon. And it will be a single ground over here. But in case of the negative end, we're gonna connect it to different pins. So 13, 12, 11, 10, 9, 8, and the 7th pin. All right. Let us see if our code is working as of now. Yes, it's working. So what we're going to do is we're going to change these LED colors. I'll change the color of the LED to, let us say, yellow, then orange, then blue, then I guess white. Do we have more colors over here? I guess we are limited to colors. So no worries, I'm gonna try with these colors as well. And if you go to the code, as you can see, we have 13 high, 13 low at per 100 millisecond, 1000 milliseconds. So I'm gonna enter it and copy the code and just change the numbers. So the second, it will be 12 high and 12 low. Then it will be 11 high and 11 low. Note that these 13, 12, and 11 are basically the pins which are these connected. So let us try. The first one is glowing. Now the second one is glowing. And now the third one is glowing. As you can see, we have these things as of now. It is in loop 1, 2, 3, 1, 2, 3. Let us connect a different and different basically LEDs, other LEDs also here. So it's gonna work over here. So it will be 10, 9, 8, and 7. All right. So let me quickly paste the code over here. There are, of course, you can arrange all the codes together. It won't be an issue. Uh, Ramakant, we are using Tinkercad as a software here. It's an online emulator for circuits as well as other 3D prints. And we're gonna do it. If you want, I can give you a demo soon. Once again, it won't be a problem for me. Okay, 9 is done. We're gonna do 8. All right, I messed up somewhere. Yes, 9, 8. Okay, 10 high. All right, I missed it here. 10, 9, 8, 8, and it will be 7, 7. I guess this should work now, and it should work on 1, 2, 3, 2, 3, 4, 5, 6, and 7. All LED lights are glowing. Any questions as of now? I guess there are no more questions. All right, this is cool. I guess yes, it's really really cool. I have been made a couple of projects. I'll show you one by one what I have made last year. Even for the one of the projects, I have made a patent, and I filed a patent here in the Indian government, and have got it. And I even have the copyright of the code as well. I'll show you that project as well, which I have made along with my team, and I'll also give them a shout out as well at the last of the session, so you can also explore how what and how we made it. So here we have made. So let us quickly stop the simulation and make some other pattern. Now let us see. Let us lower the delay a little bit to, let us say, 500 milliseconds. So okay, it's a very big deal for me. I won't do it. It will take much time to change all the thousands into 500. All right. So this is something you all can try over here, and there are a couple of interesting projects you can also make. Hi Gaurav. Basically, you don't need to call me sir. You can just call me Khalid. And I am particularly exploring hardware on emulators. And in this case, we are using Tinkercad as a software for emulators. Particularly, we have making kind of a jingle light or a LED light kind of thing. If you want, I can explore and write some initials over here using LEDs. We can use different types of software as some different things as well, different hardwares to explore different kinds. Uh, so just a second, my screen went off. I'll quickly open up again. By the time, if you have any questions, please feel free to ask here. I'll be happy to answer. And also please ignore if my voice is breaking, not ignore particularly, but if my voice is breaking, please, I'll please forgive me because of it's heavy rain here, and it's kind of network is kind of glitchy over here. No worries. All right, let us quickly bring back my screen. No, Joel, we actually made something very cool. If you want, I can quickly show you again what we made. It is particularly a Christmas lights using Tinkercad. We made it. It is very simple projects if you have explored hardware before, but it's kind of interesting that we are doing everything on our emulators. And know that if you paste these codes and made different like similar kind of joints, and if similar kinds of hardware you use and use the same code, it will work actually as same. It is working on emulators. Basically, I use these emulators to test out my code before blowing up my Arduino. So this is kind of a playground for me to test out hardwares. So we made this as of now. Now we're going to explore different types of hardwares we can make and different types of things you can do on Tinkercad. These are some of my old projects which I made along with my friends. So let us explore some of them. All right. Let me quickly go back. You can also use buttons to give out the code, and if use an if else loop, so it will work exactly the same for you as well. So this is what we call a segment decoder. If you have studied digital electronics before, it is something that will come in your course. So as you can see, if you go for the code, I have initialized different pins for different variables and then give different pins an output and loop. So if particularly if you see this particular switch is A is low, B is low, C is low, and D is low, all the lights will be on. If you say if A is low, B is low, C is low, and D is high, that is only the D part will be on. Then there'll only certain LEDs that will glow. Now, if I've used if else condition everywhere, so it will be easier for you to have different things at different modes. So if you are working for a jingle light or a Christmas light or a Diwali light, you can use different modes and make your own decoration at your home. This is something we made in my first year of the college. And also let us explore some different things over here. All right, I made one thing which I had made a patent of. Let me quickly find it over here. If I have it, yes, this is the code which I'm talking about. This is basically an automatic doorbell or COVID doorbell. I'll quickly show you the model as well to explain you how things work over here. So this is basically an automatic doorbell that will sense the temperature of the person who is ringing the doorbell, as well as it will indicate the person inside and outside, and also sanitize their hand, and also show the temperature of that particular person. This is something we made last year and made a patent of. Kudos to my team, Himanshu, Jasketan, Anmol, and Umang. We made it during our own some kind of hackathon and submitted over there. Although we didn't win, but we found this particular thing very cool, so we filed a patent of it. Anyways, let me quickly give you a demo. So in case we put a hand in that is here, the proximity center, it will sense the temperature. And also, guys, did you hear something? It's basically the alarm which went on. I use the Harry Potter theme. Just let me know if it is audible enough or not, or I'll screen share again. Was it audible? Sorry. All right. I'll quickly show you again. So in case we put the hand in, so as you can see, the current temperature is 76.47. Now, if I increase the temperature, note that I'm a big Harry Potter fan, therefore I've used a different tone for Harry Potter things. So if I increase the temperature and put my hand again in, as you can see, it is putting up an alarm and also a red LED is glowing out, noting the person who is outside the door is of high temperature and it should not be allowed inside considering the current COVID norms. So what do you think about this product? Not particularly the product is project you can say out. This is something we were trying out of exploration and exploring it over hardware. And note that we made it over here and then made it in hardware. So it was completely an idea over Thinkercad and we made it to the real product. If you want to see, I can show you a demo and other things you can do on Thinkercad. If I go to 3D designs, you can see the 3D design of my product as well. So this is something I made for that particular device, which I really showed off. I can also show you the code as well. So this is something the outside unit of the product. The person's hand will go somewhere here, and you can see this. Sorry, this groove is for the temperature sensor. We're going to use an IR temperature blaster. Sorry, temperature sensor. So it's going to sense the temperature and put it over the screen. Here is Here is where the sanitization module put up. We put the sanitization module over here, so it will sanitize the hand over there. And for the inside unit, we also made a prototype. We also made it. I do not have the photograph as of now. Yes, I'll show the code as well. It won't be a problem for me. So I'll put it over ThinkCAD, and it was the inside unit will show the temperature and also the buzzer. As you can see, we have the Arduino as well inside the temperature, inside the unit. And also let us quickly go back again and show you the code as well. I'll explain the logic as well for all the things these kind of things. So it will help you to build yours. Note that this servo motor is actually the sanitization module. Since it cannot be depicted whole together in the emulator, it will only show the code part and the hardware part. So as soon as this moves, this will actually sanitizing the person's hand. This is temperature module. These are the LEDs red and green for danger and not the danger. This is a PIS sensor. Sorry, PIS sensor. It's the proximity sensor we use. So whenever some person put their hand near the particular sanitization module, their hand will be sanitized and also temperature will be taken. If you go for the code, we have defined nodes over here. Note that we haven't coded all the sound you are hearing. We just copied it from an open source software, the sound, the Harry Potter tone. And we have initialized the value of the temperature at 0. Temperature, there are different things we have done. If you see the pin mode 5, 3, and 2, if we go here and 5, 3, and 2 are connected to the piezoelectric sensor, the temperature module, and the servo motor. So we have initialized it. Then we're going to have the digital read 7. Long duration digital read 7 is for the PIS sensor. So if we this if and else tone is for the melody, and then the serial print in it is for the LCD screen. Note that this is the code as of now. It's a very short code, I guess 135 lines of code, but is working perfectly. I'll give you a demo once again. So note that if I'm a person whose temperature is more than the normal temperature, that is 97 degree or 99 degree, and if I go somewhere near this temperature module, although it will sanitized it. All right. Temperature is 199 degree. This person is boiling, to be honest. This is not the actual temperature a person can have, but it's just for example. It will also show the last temperature record, that is 99.5 degree Fahrenheit. We can change it to the Celsius as well as per the code. So this is something we have done. The music notes are not inbuilt to the software. You can search it over the net. If you go over Google and search for piezo buzzer music for, okay, I guess my screen is not audible. So if I'll screen share once again, the the thing is I do not have my second screen, so it's kind of tough for me to screen share most of the things over here. Well, you have the music codes over here. You have different music codes. You can find it over net. We just copied it from net because I really liked the Harry Potter tone, although it's not as attractive as the original one through the piezo sound, but it's still a good one. So you can find these tones over this open source repository. I'll quickly share the screen as so not particularly the screen, but the repository Abhishek made it. Kudos to Abhishek. I don't particularly know him, but it's a really good repository. So coming back to what we were building, let us quickly make something attractive, or let us quickly write my initials using Tinkercad, and then we can have your questions and then end the session. So let me quickly go up and create a new socket. Folks, do you have any questions as of now? I'll be happy to answer if you have any questions. Is this downloadable? Means Tinkercad? No, it's a web-based software. So you're gonna work. You need to work it over here. There are other emulators as well which works offline, but I haven't tried it, so I won't advocate it. But you can find it over different places. As of now, this is the free and the open source version for trying out emulators. Not particularly open source, but it's a free version since Arduino is open source, and this is a free version. You can try out different Arduinos over here. So let me quickly put up another board over here. Let me take Arduino Uno, decrease the size and breadboard small, and let me try and write out my name as an initial, or let's write init. I guess init would be more. I need to take a big breadboard since init is a very long statement as far as ILEDs are concerned. All right, so let me quickly take some LEDs. Let me have a register. And let me check if it's somewhere. I put it over somewhere right. And let me connect this thing to 13, which is gonna power source, and this particular point to. All right, I did a mistake. I connected both of it to the positive end. Although it was still gonna work, but I'll do it for the best practices. and connect the negative into the ground. Let me quickly check the code. Let us this have 13 and 13 high, 13 low. All right, it is not working, not particularly sure. I guess there's issue with the power supply because the light is glowing over here. I think I might have blown my LED. No worries, I'll try it again. All right, I guess I did a negative positive mistake. I'll quickly try it again. Sometimes these hardwares like these actually Tinkercad is kind of glitchy. It sometimes do not work, but you can confirm that if the project is or the code is working by clicking this light link. It is if it's blinking or not. So let me quickly check it. And I'll put the negative one over here and let me check it. Yes, only one light is blinking. I guess there's a direct connection. Oh, okay, all right. All right, I understand what I've done. No worries, I'll fix it. Note that these things are not connected to each other. These boards, I forgot I'm using a large Arduino board, so I need to connect these folks again. So it's still not connected. Okay, the second one is also needs to be go to ground. All right, get this and okay. All right, all the links are blinking. We have now have to write NIT in it. So let me quickly copy all the things. I'm gonna do it once again and copy it. Connect it. I guess it's gonna take me some time to build it, but I'm gonna still try it for you folks. Right. Let's connect and register from here to here. And this is well to the positive end. I guess it should work now. Yeah, it's working. Uh, okay. Now we have to make this eye also glowing. Sorry, and the other part of the N also glow. We can do that. It's pretty easy. If you want, I can show you guys. Writing in it on an LED screen, that would be very much easier. I'll show it if you want these guys. I'll show it to you. Not a big issue for me. I'll show it that as well. Although connecting an LED is kind of a big job, so I'm gonna do it. Show it to you. Just give me a second. All right, I'll screen share it to you. That won't be a problem for me. All right. So this is the LED template we are using. I'm not gonna write the whole code because it will take time, and it will also take time to connect all these LED because it's a seven segment LCD. Sorry, LED screen I'm talking about. It's an LCD screen. It's a seven segment LCD display, and I believe yes, it takes some time to connect all these. So I've already connected it, and these are liquid crystal display code, example code. So what we're gonna do is first we have to include the library of liquid crystal display. So it will be liquid crystal.h. In case you remember, if you worked on C++ before, we usually write include studio.h, conio.h, and these are the things we do usually while working on C or C++. Then we have to set up and begin LCD1 begin at 16.2. If you go over here and it will, you can see it is connected on uh, different ports like 12, 10, 5, 4, 3, 2, 1, and it's beginning on 16 and 2. Note that another thing, that if you work on the code, we're going to loop it and show the screen sensor at 0, 1 and print it on the screen. So I've already added MLH in it. It is going to counter it at 1. So it is 1, 2, 3, 4, counting it till infinity as it goes. So you want me to do this cypherpunk, or you want me to write it using LEDs? I can do both of it, but the LED, using LED, it's gonna take some time. Anyways, as far as is there any questions, I'm happy to answer any of the questions regarding to Tinkercad, or any of the questions regarding to what what is community, what is MLH. Some of the questions I can answer. Although Mary and Ryan will be coming, I guess today Mary is only taking the session, so Mary will be coming live in 1 hour about. So I guess 9:30. Deep Pandey, I guess in this particular session we are not having any swag giveaways, but for sure for swags you can check in to all of the days. I guess we still have the swag for all policy for MLH MLH Global Hack Week INIT participants. So do check in and do attend all the session. Also, if you are working with the guild, and you can get some extra stickers by attending all the sessions. Anyways, are there any more questions? I'm happy to answer any of those questions because we have been live for about 55 minutes and I guess we have explored most of it. So if you want, I can quickly give you a recap as well. Cyberpunk, yes, you can for sure submit Tinkercad projects in a hackathon. Although we do allow some of the hackathons do allow emulator submissions, some do not. So it would be great if you check in with these things. And I guess if the judges are fine, I guess they won't discriminate in emulator based projects and the hardware projects. Although it is quite easy to make projects on emulator, but the logic is pretty same if you're working on hardware projects as well as software. Sorry, hardware projects or the emulator projects. So, any more questions? I'll be happy to answer any of those questions. Anyone? If you have any feedbacks, if you have anything, Note that if you are still attending the session, please check in for this live session. I'll surely share the live link as well. For check in, just give me a second. Get the check-in link for this particular live session. And if you, in case you haven't checked into the day 6 of Global Hack Week, please do it via this particular link and you will be good to go. I'm, ima- you are imagining making a keyboard right now. I don't know how, I don't know why a keyboard specifically, but it seems really cool. I actually made one keyboard using, I guess, Tinkercad itself. Let me see if I have it, but I guess it was on some other account where I use these piezoelectric sensor and different plugins or different buttons to actually produce different sounds and different buttons. You can do it. If you do so, don't forget to tag this particular session on Twitter and also ML Hacks. So it will help you to. I'll love to see all the projects, and I'll also love to review and comment on those projects. Do you have any more questions? I'll be happy to answer. In case you don't know me, I am Khalid. I am an APAC coach for Major League Hacking. I help organizers help organize hackathons, and also I'm into developer and developer advocacy space. So if you have thing related to that, I'll also be able to help it. Deep particularly you're asking for resources to get started with these projects. First of all, if you are starting with anything, please go through documentation. If you want to get started with Arduino, or some people spaces that Arduino, I'll quickly share the documentation for that as well. You'll be able to find it and work on Arduino for different things. I guess, yes, this is documentation link. If you really want to work on Arduino, you can find these docs and go through it, understand the product, and then start working on it. There are different boards, different Arduinos. Note that Arduino Uno is the basic of all. It is the most common thing. You try it over anywhere, like if you're working on like basic level projects, Arduino Uno is best. If you're working for something small, Arduino Nano is. But since Tinkercad only provides Arduino Uno, we have made different things on Arduino Uno. All right, let me quickly check if there's another project I can demo you to all so you can understand it. Sorry for that sound. I guess something is not working at my computer. It's making some weird sounds. Anyways, documentation. All right, Deep, there are two questions, I guess, for the documentation as well as for the Arduino. I would suggest to try the real Arduino once because it's really an amazing experience. Although emulator can do lots of stuff, but it's not as sufficient because you cannot work on cloud on emulators. As of Tinkercad is concerned, you cannot work on clouds directly. While if you want to look forward for some basic level projects, I guess emulator is enough, but I'll still suggest you to work on direct Arduinos, because that working on Arduino is really an amazing experience and it will really help you to learn a lot in IoT. In case you don't know, for Internet of Things, there are two different components. One is the sensors, and second one is actuators. The sensor is the one who senses in the things, and actuators are the one that acts on different things. So if you work on the projects, it will really help you to understand it. Cyberpunk, I guess documentation is sometimes very boring, but it's why it's very insightful. In case you are not liking the documentation, you can go out some demo videos, because I guess most of the folks like videos and tutorials more than documentation and reading to blogs. Even I'm a particular person who do not like videos, and I am person who mostly go through documentation and tutorials which is in text. It's actually helped me to save time and learn a lot. Also note that if you're working or learning anywhere anything, make sure you do write, you try it most of the things by hands on. Reason being, if you just keep watching out these session, it will be ended up ending into a tutorial loop. So make sure you do try out the session. I love to see your projects. If you make something good on emulators, please do share it on my Twitter or tag Major League Hacking, or share it on Discord, of course. It will really help you to understand what it is and how things work. And make sure do share it on Discord, MLH, like is Global Hack Week chat. I'll be love to see, and do tag me as well to really help me to see it. I'm really excited to see all your projects. All right. I guess many of the folks have learned some experience projects. All right. Which Arduino is for purchase as beginners in India? I guess Arduino Uno. You can get the Arduino Uno kit for, I guess, a couple of thousand rupees. It won't cost you much. I guess 2000 or 2500, if I'm not wrong. Also, if you are a college student, you can get it from your college lab if they have it. I used it all my college supplies in learning Arduino, so it was pretty easy for me. Know that you can try out different things over there. You can also try out different things like Raspberry Pi and all for learning IoT. I guess Ritvi did had a session for IoT last in it. I'm not sure about this session, but she did had, and she explained really well on making projects and collected it to the Azure cloud. So you can try out that as well. All right. Can you show some projects on emulator? Deep, I did show you some projects on emulator. I can show you again. Let me quickly screen share again so you can have a look on how far you can go on making building an emulator projects. Let me quickly screen share on ThinkCAD again. This reminds me of something. Last year we had a challenge on INIT where I was a participant. We made something to write it on 3D, so I made, and our team made it like that. So in case you remember it, if my folks are watching, if you can remember, we made this 3D thing over there on ThinkerCAD. Atulya, Sonal, Umang, me, and Shrey made it. It was pretty easy to do so, although we made all different kinds of things over here. Some of the likely Harjot wrote his own name. We made different 3G projects, like I made a doorbell and something. I really keep exploring Arduino or emulators. It really helps me to learn to understand. Well, let me quickly show you. SINK, the SANIC project, we made it. We had a patent of it last year. It really helped me to understand most of the project. We did make it over hardware as well. It was a standalone project that helped me to that help any person to keep themselves secure of COVID-19 infected person based on the temperature. So in case you see this particular thing, this is known as a microservo motor. This actually does not move in a complete circle, but like moves in 90-degree and then stops. So it is really helpful for using sanitizer. This particular motor, we have used it for sanitizers. This is a temperature sensor. Here, of course, it's in normal temperature sensor, but in case we use an IR temperature sensor, these LED bulbs are red and green. We used it for showing danger and not danger. This is a piezo alarm or a piezo buzzer that helps you to buzz the sound, either it's a doorbell or the person is infected. This is the proximity sensor, PIS sensor, and this is an LCD screen, of course. So if we start the simulation, first, I guess it will show me to put my hand inside the temperature sensor of the doorbell. If I do so, it will automatically sense the particular temperature, and also the micro servo motor will turn down. Okay, so in case the micro servo motor, I guess you set the move and the temperature, the basically the sanitizer is sprayed and also temperature. So the last temperature is 76.47 degree Fahrenheit, which is quite of low for a person, but it's still a demo project. So it is normal, and the person can go in that budget. The sound works as a doorbell. For a particular session, if I increase the temperature a bit, for example, let us increase it to the maximum, the person is going to boil, of course, but it's just for a demo. So the doorbell, let me finish. All right. So doorbell is gonna finish, and then the buzzer will sound it along with the red LED. That shows the person is 256 degree Fahrenheit, which this particular thing is blowing, but it's still a demo project. So as you can understand, this project we made. If you want, I can show you the 3D model as well. I'll show you just a second. If you go over here, the 3D designs, I have made a 3D model as well for it. It was the outside unit. I'll quickly show it to you. It was the outside unit of the projects. I'll view it in 3D. This project is particularly a private project, but if you want, I can open source it and send it to you in a while. So as you can see, this is the 3D model of the particular projects we made. This is the outside unit of the projects. The down hole is for the temperature sensor. The left hole was particularly for sanitization. This shows the temperature, and red and green LED for showing out danger or the high temperature, low temperature. We also made an inside unit of that particular box. Sorry, I'll put it in 3D as well. All right, this is something weird. I guess I haven't chose it the correct one. All right, this is not working. I'll tinker it and show you. Sometimes demos do not work, but it is really a good software. So you can see we made an inside unit where the real Arduino was, and as you can see, we have the buzzer, we have the LED lights, and also the temperature sensor. So this is particularly you can make these kind of projects on emulators, and I'll really love to see all your projects over here. Do we have any questions? Yes, for sure. If I open source that particular projects, I'll surely send it to or put it on my Twitter or put it on my GitHub so you can have a look. So if you have any more questions, I'll be happy to answer. And in 1 hour, we're gonna have the last day of MLH INIT to start, and it will be really an amazing journey. For 6 days, you have been hacking. I guess tomorrow you will be getting all your final projects, sorry, final coins as well as your confirmation of swags. So I guess many of the folks have understand what I actually tried you to teach. But if in case you have any doubt, please feel free to put it over on the chat. If we are working with some projects where we can reach out to you, you can surely reach out to me over Twitter or LinkedIn. My Twitter ID is on the screen, as well as LinkedIn is Khalid K799. If you search it over net, you can find it. I'll be happy to help. And all, of course, if I'm not able to help, I can also connect you with some amazing folks who have done much more in IoT than me. So it will be really helpful for you to understand and help, of course. Any more questions, folks? All right, I guess we don't have much questions, so we can, I guess, end this particular session. And all right, note that in case you haven't forgot, if you haven't checked into the event, please do it. I will share the link again so you can earn some extra points and as well as extra stickers if you haven't. I'll quickly open up the docs again and share the link with you. This is the event link. Thanks, Cyber, and thanks, Deep. I'll be surely coming back again with some other local host events or MLH Init or MLH Global Hack Week sessions. You can also find me over Twitter. I take Twitter different sessions as well. So if you want, you can reach out to me everywhere. And also the Discord, the Ability Community Discord. I love to see all the projects you made on hardware over the Discord. So if you had made anything on emulator or hardware, I love to see it. Please put it on Global Hack Week Init chat, and don't forget to tag me. I surely love to see these projects. So that was all from my side, and we'll be ending the session. So have a great day and keep hacking. Bye.